Okay, so this is a video on composite functions. Composite functions is an area of the Unit 3-4 course that we don't cover in Unit 1 and 2, so this should be theoretically new to most of you. So composite functions are what results when we apply one function after another function. So essentially, we take some numbers, some x values, and we stick them into our first function f. And function f does whatever function f does to them. Maybe it's double and add 5, maybe it's square and take away 2, whatever. And then it spits out new numbers that we call the range of f, okay, or f of x. And then what we do is we take those numbers f of x and we sub them into another function g. And it does its thing with them, whether that's to, take the square root and subtract 4 or whatever it might be. And then it spits out the final values, which is g of f of x. So we've taken our x values, we've applied f to them to get f of x, and then we've put all of those into g, and we've ended up with g of x. Okay, so we compose the two functions. All right. So first dot point underneath here, a composition of f followed by g, which is what we can see in this function machine diagram up here, is denoted by g, this little circle f, and we tend to read that as GOF. Okay. Now I must say, VCA don't tend to use this notation in the exam, but it is really common in your textbook. And it is coming in the static design change. So GOF is g of f of x. That's how I would read that. And so we would write that like this, g of f of x. Okay, substituting f of x into g of x. We're subbing x into f to get f of x, and then subbing f of x into g to get g of f of x. Okay. If we compose the functions in the reverse order, a composition of g followed by f is denoted by FOG, f of g of x, and that's where we take x, we sub it into g first this time to get g of x, and then we sub all of that into f to get f of g of x, f of g of x, FOG. So that is when g is being applied first and then f. Okay, there's a really important moment that happens here, okay, that we need to ensure works correctly in order for the composition to exist. So what we need to understand is these x values here that we start with, we call the domain of f, and it gets subbed into f. F turns them into new numbers, which we call the range of f. Okay, but then we're going to make the range of f become the domain of g. So the range of f has to be able to be the domain of g. And so what that means is that the composition can only occur if the range of f is a subset of or equal to the domain of g. Okay. If, for example, the domain of g is only r plus and the range of f is r, we're going to have a problem because we've got numbers coming out of f that cannot be substituted into g. Okay. So it's all about ensuring that issue in the middle there can be dealt with. So the range of the first function, or when we look at it in this notation where it's going to be g of f of x, okay, the range of the inside function, so all the numbers that are going to spit out of f, they have to be able to fit into g. So they have to be a subset or equal to the domain of g. Okay, so for a composition to exist, the range of the inside function, I use that term inside loosely, of the inside function must be a subset or equal to the domain of the outside function. Okay, so if that doesn't happen, then we cannot perform the composition. We cannot calculate GOF or FOG, depending on what it is. So for GOF to exist, remember GOF of x is g of f of x. So f of x is the inside function. We need the range of f to be a subset or equal to the domain of G. And if it's not, then the composition can't occur. Or we need to restrict the original domain of F so that the range of F isn't so large, so that it instead will become a subset or equal to the domain of G. The domain of a composite function, so let's go back to our machine up here. So the domain of GOF, G of f of x, here's the x values we started with up here. The domain of the inside function, that's the original x values that get subbed in right at the beginning, that is the domain of the composite function. Okay, so the domain of a composite function is equal to the domain of the inside function. So domain of GOF, remembering that GOF is G of f of x, so f is the inside function, so the domain of GOF is just equal to the domain of f. Okay. The range of GOF must be considered for each case, so you must then think about, okay, well, what domain did I start with, and given the rule that I've ended up with for GOF, what does that mean for the range? So you've got domain and rule, those things together must be combined for you to be able to think through what the range is going to look like. Composition of functions is not commutative. Okay, so let's talk about that word commutative. Addition is commutative, multiplication is commutative, subtraction is not commutative, division is not commutative. So it's about whether you can reverse the things. So for example, 2 plus 3, 3 plus 2, they're the same thing, it's a commutative operation. 2 times 3, 3 times 2, they're the same thing, it's a commutative operation. However, 3 minus 2 and 2 minus 3 does not give the same thing. That subtraction is not commutative. Again, 2 divided by 3 is not the same as 3 divided by 2. Division is not commutative. So composition of functions is not commutative. That means that fog of x is not the same as GOF of x. Okay, and in some cases one of those things might be possible. Fog might be possible, but GOF might not be possible, or vice versa. And certainly, even if they're both possible, we would get different rules. Okay, let's work through some examples here. So given that f of x is a simple linear function, 2x minus 1, and g of x is a basic square root function, where possible, find GOF and fog and state the domain and range of each. Okay, so it's really important before you launch into any algebra to consider whether or not the composition can exist at all. So let's think those things through, and we're going to need to be able to think about domains and ranges. So I'm gonna just articulate. Well, let's think about each. Let's think about GOF first. Okay, so for GOF, f is the inside function. It's g of f of x. Okay, so it's g of f of x. So f is the inside. We're going to need the range of the inside function to be a subset of the domain of the outside function. Okay. So let's consider what those sets are first of all. So, sorry, we don't need the domain of f, we want the range of f. So f is a linear function, so the range of f is r. And the domain of g, now g is a square root function, so that's 0 to infinity, inclusive of 0. Okay. And so since the range of f is not a subset of the domain of g, GOF is not defined. So we're not even going to try to calculate it. We're not going to work it out. We can't state its domain and range. It's not defined at all. Okay. So that was GOF. Let's now think about fog. Okay. So fog is f of g of x. So we want the range of the inside function, the values that spit out. So we put x into g, g spits out its range, and then those numbers need to be able to go into f. And so we need the range of g to be a subset of the domain of f. So we need to calculate those things. So range of g in this case, now g is a square root function, remember it looks like that. So its range is from 0 to infinity. And the domain of f, that's a straight line graph, so the domain is just r. Okay, and so in this instance the range of g is a subset of the domain of f, and so the composition will exist. Okay, so since the range of g is a subset of the domain of f, fog is defined. It's really important if you're going to justify whether or not fog or GOF is defined, you can't just say that the range is or the range of this is or isn't a subset of the domain of this without actually stating what those ranges and domains are. Okay, you must make your answer specific to the question. It's not just about making a generic statement about composite functions. You must actually think about the functions involved here and calculate the relevant domain and range for those functions and draw a conclusion from that about what that means as to whether the function, the composition is possible. Okay, so this one is defined, so now we're going to calculate it. Okay, so f of g of x means f of g of x, okay, which means f of square root of x, which is g of x, and f of x is 2x minus 1. So our rule here is going to be 2 times the square root of x minus 1. Okay, so what we're doing is we're substituting g into f, so everywhere there's an x, we're replacing it with a root x. Okay. If it was the other way around, if the composition of g of f of x had worked, we'd be taking f and subbing it in place of x, so it would be square root of all of 2x minus 1. Okay. So again, your function notation needs to be good to understand what's happening here. So we've calculated the rule. So we've found fog, which is 2 root x minus 1. The domain of fog is equal to the domain of the inside function, which in this case is g. Okay, and g is our square root function, so its domain goes from 0 to infinity. Okay. And then we want to think about this domain coupled with this rule in terms of what that means. So thinking about this is 2 times the square root of x minus 1. So it's the square root graph dilated by 2 from the x-axis and translated down by 1. So it's going to look something like that. That's 0, negative 1. So the domain of g isn't in any way a restriction of that. That's in fact the implied domain of that rule. And so the range of that is going to be, so range of fog is going to be from negative 1 to infinity. Best way to think about ranges is you really do need to be able to picture the graph and what's going on. Okay, so in terms of answering our question, we've got the rule for fog, where possible, find fog. So we've determined that fog is possible, we've found fog, state the domain and range. Okay. GOF we've determined is not defined, and so there's no need to determine its rule and state its domain and range. Okay, example 2. Consider the functions f of x equals x plus 2, but over a restricted domain from negative infinity to 3, and g of x equals a parabola in turning point form, so x minus 3 all squared minus 1. Okay, so let's just think about what these look like. So f is a straight line graph, y equals x plus 2, but we're only looking at that from negative infinity up to 3. So it's going to stop at 3, not including 3, so we're going to have a hollow circle there. When x equals 3, y will be 5. Okay, so it's going to essentially have a domain from negative infinity to 3 and a range from negative infinity to 5. G is a parabola right by 3 and down by 1. So it's going to be 3, negative 1, sorry. So no domain restriction, domain is R, but range, because it's a quadratic, a parabola, is from negative 1 to infinity. Okay, so show that fog is not defined. Okay, so this is what I was talking about before. It's not enough just to state a generic statement and say that fog is not defined because the range of G is not a subset of the domain of F. You have to actually state what those relevant sets are so that you've actually applied it to this problem. Okay, so f of G of x is f of G of x. Okay, so we're interested in the range of G and the domain of F. So the range of G, we know, is from negative 1 to infinity, looking at our graph. And the domain of F, sorry, I'm just going to move that out of my way. Domain of F is also restricted because of the, we're actually given the restricted domain, sorry. Domain of F is from negative infinity up to 3, not including 3. Okay, so negative 1 to infinity is not a subset of negative infinity to 3. There are numbers in this set that don't fit into this set. For example, positive 5 fits in here, doesn't fit in here. Okay, so therefore this does not fit entirely into here, and so therefore it's not a subset. Okay, so therefore, since the range of G is not a subset of the domain of F, fog is not defined. But as I said, you can't just make this statement without actually providing these sets, okay, for this specific example, all right? Okay, so then part B, this is quite a common kind of question. By suitably restricting the domain of G, obtain a new function, G star, so just a modified version of G with a restricted domain, such that f of G star is defined. Okay, so f of G is not defined because the range of G is too big to fit into the domain of f, okay? So now I'm going to also say, I often say things to make this more understandable to you, but it's not acceptable to write down, you know, the domain G doesn't fit into. We want to talk mathematically, we want to talk about it being a subset or not being a subset, so make sure you're using sort of appropriate mathematical language and notation when you're writing things down and you're answering questions. But, you know, we can have a more flexible understanding of that in terms of the way we talk about it verbally to help you understand what's happening. So the problem at the moment is that the range of G includes numbers in it that are not in the domain of F, okay? So at the moment, G of X, we know, is a parabola with its turning point at 3, -1, okay? I'm just thinking about, yeah. Okay. And at the moment, we need, for the composition to exist, we need the range of G to be able to fit into -3 to -infinity to 3. Now, we're not going to be changing where the turning point sits. We're not translating the graph. We just want to restrict its domain. So the domain currently goes from, the range currently goes from -1 up to infinity. And the problem is that we need it to stop at 3 so that it will be a subset of the domain of F. Okay. So, sorry, I'm having trouble erasing that. Let's try again. So we need the range of G to be equal to, we can't change the -1, sorry. It's going to go from -1, but we want it to stop at 3, and it can't include 3 because 3 isn't included in the domain of F. So we need to stop at 3, wherever 3 is. We need this to be the function G, okay? So this is y equals G of X, sorry. Alright, so we need that to be y equals 3, okay? So that its range is now just from -1 to 3, not inclusive, and then if its range is that, that will be a subset of -infinity to 3, not inclusive, and therefore the composition will exist. So sorry, we need the range of G star to be that, which is our modified version of G, okay? So to work out, but we can't restrict a function by restricting its range. That's not how functions work. Function is about domain and rule. X values, what you do to them. So we need to work out, okay, well, what does this mean for the X values so that we only get a range that goes from -1 up to 3, which means we want to restrict the domain of our function to just be between these two X values here, okay? So we need to work out what those are. So we need to let our function g of x equal 3. Okay, so we need x minus 3 all squared minus 1 to be equal to 3, which is x minus 3 all squared equals 4. So x minus 3 equals plus or minus 2, square root of 4. And x is 3 plus or minus 2, which is 3 minus 2 is 1, and 3 plus 2 is 5. So we need to restrict g of x so that it just goes from 1 to 5, not inclusive, which would mean that its range is from -1 to 3, not inclusive. Okay. So therefore we need the range of g star, sorry, not the range of g star, the domain of g star is going to be from 1 up to 5. And if we make the domain that, the range will be what we need it to be, and therefore the composition will exist. Okay, so let's just make sure we've answered the question. By suitably restricting the domain of G, obtain a function G star. So we want a function G star. So a function involves both domain and rule. So G star has domain from 1 to 5, and its rule is still going to be the same as the rule for G. So that is x minus 3 all squared, take away 1. Okay. And now if And now if the range of G star would be this, therefore that's a subset of this, and therefore we can work out the composition f of G star. Okay, it's not asking you to do that composition, it's just asking you to define G star so that f of G star is defined. Okay. Alright, so some questions here from exercise 1E to be working on today.